Well, for a little bit more on this, we're now joined via Zoom by Dr. James Butler, who's a member of the Neurological Association of South Africa. Thanks very much indeed for joining us, and welcome to the program.
Thanks, Peter.
All right, I suppose the obvious place to start is, what on earth is epilepsy?
Well, it's actually a bit of a controversial definition of epilepsy. So just to add to your introductory remarks, about 1 in 10 people, 1 in 10 of us on the planet, of what are we, 7.8 billion people or something, 1 in 10 of us are going to have a seizure in a lifetime. So that's an epileptic seizure. And currently, for a long time, epilepsy has been defined by the occurrence of more than one seizure, more than 24 hours apart. But even that's a bit of an arbitrary definition, because you never know when someone has one seizure whether they're going to have more or not. So your number is quite correct that at any particular point in time, 1 in 100 people in the country will have epilepsy, which is recurrent seizures, a propensity to recurrent seizures. And in virtually all instances, or most instances, will require some sort of treatment. So that's really what epilepsy is. And a single seizure, an epileptic seizure, is really just a very brief electrical storm that happens in the brain. And depending on where it happens in the brain, it can present in different ways. And there are many different causes. So to sort of elaborate on the definition, I rather prefer the term epilepsies, because there are many causes and there are many ways in which it can present. And moreover, it's a very common problem that is often not disclosed by people, primarily because of the stigma and the shame that it supposedly brings on people. It's nothing more than a medical condition, common as you hear, and you'll know people who've got it. They may not have told you. People from all walks of life, all socioeconomic strata, et cetera, and it spares no particular sector of the population. We're all at risk, as it were.
All right. I'm curious a little bit more about the mechanics of it. So in our brains, we've got electrical pulses that are going all the time, and I suppose this is sending messages to various parts of the body to do X, Y, Z. So when a seizure happens, what happens? Are we seeing that these electrical impulses and signals are scrambled, or what happens?
Yeah, so in essence, you might know that the outer bit of the brain is called the cortex. It's a thin little gray matter, and then most of the brain is occupied by, as it were, the wires, the telecom wires, and those are just fibers. So the brain cells, so the cell bodies are constantly talking to one another, a bit like you'll have when you go to a rugby or a football match or a soccer match. And there are people nattering away, as it were, all the time. That's what brain cells do when you're awake and when you're asleep. And they're talking to neighbors and to other members of the population of billions of brain cells that we have. And there's this sort of oscillation that goes on all the time at a macro level of potential differences between the inside and outside of our brain cells. Now, a bit like a soccer match, when a try is scored in rugby or a goal is scored in soccer, what happens, the analogous situation in the brain is people, of course, stand up and shout and scream, and they do so together. Now, in an epileptic seizure, a very similar thing happens. Groups of brain cells fire off, so large numbers fire off excessively and in unison, or in synchrony, as we call it in epilepsy. And it's that process of an excessive, as it were, an electrical storm that happens in either parts or regions or sometimes much of the brain that defines an epileptic seizure. So it's defined by what happens electrically and physiologically in the brain, not by what you see.
All right. Is it hereditary? Are certain people prone to it, more vulnerable to it? Or is it just pot luck?
Well, much of life is pot luck and much of health is pot luck. But you're absolutely right. There are many causes. So in principle, anything that happens that's abnormal in the cortex can cause an epileptic seizure. And the most common ones actually are genes. So if you inherit a complex of genes, it often doesn't run in families. So each little brain cell's electrical functioning is determined by many, many genes. And depending on the combination of genes that you have, some of which you get from your mother, some from your father, and some of which are mutations, unique mutations. That complex is what causes epilepsy very commonly. And that's the reason why, because our genetic program is constantly changing, you'll hear of people who develop it, let's say at the age of 5 or 7 or 10, have it for a number of years and then outgrow it. And that's really just the genetic code that's running its course. Just like your face changes throughout life, the electrical wiring, as it were, in your brain is ever changing. So that's a common cause. Yeah. And then another common cause is just little birthmarks that you have in the brain, just like you have them in the skin. They can they do occur in the brain. And although the nature of them is completely innocuous, as little birthmarks in your skin are, they're a common cause for epilepsy. Yeah. The nastier conditions like brain tumors and encephalitis and meningitis, and those are rare causes of epilepsy, or infrequent causes, should I say. And the much more common ones are little birthmarks, and genes. And then there are a host of other causes, infections. If you've had a previous infection in the brain, tuberculosis or neurocysticercosis, which is really just the egg of the tapeworm, those sorts of things can cause seizures. But in principle, anything that goes wrong in the brain can cause seizures. And sometimes it's not so much wrong as you pointed out, it's pot bad luck, and you've, as it were, drawn the slight short straw of the genetic lottery. And you've got the wrong combination of genes, or you're born with a little birthmark in your brain. Yeah. So when someone comes and sees us, we try and work out what the cause is.
We're running out of time, but I do want to end on a positive note. And by and large, there is good help, good medicine to make it manageable.
Unquestionably. So if you take populations of people with epilepsy, as you pointed out, 70% of people can be fully controlled with medication, on half of them even without it, because they outgrow it eventually. And then those who continue to have seizures, depending on the resources that are available, you can help many of them furthermore with things like epilepsy surgery, where we actually take out a little bit of the brain and remarkably improve their lives considerably without harming them.
Dr. James Butler, thank you very, very much indeed. Great talking to you. Your insights greatly appreciated. Thanks for your time.
Great pleasure, Peter. Take care.
Thank you.